do here is go through Floyd, Warshall, or pair shortest path by hand so that you can see how we go about how the calculations happen. What I've done here is I've initialized my, I've looked at my graph and I've made my initial table. This is the same as the matrix, I'm just using the word table. So we've got our main diagonal of zeros. Change that. So we've got our main diagonal of zeros here, and then as well as that we've put in the distances that we've got. So from A to B has a distance of 3, I've put a 3. From A to C has a distance of 5, I've put in 5. We can't reach D from A, there's no path going there, so as a result that is infinity. And I've gone and filled up that table before I started this. Now what we're going to do is we're going to use the first row and the first column to work out all the other values, excluding the main diagonal. So we're going to refer to the first column, first row, and we're going to work out the rest of them. I'm going to do that over here. So I'm going to rewrite this table, and I'm going to write it, hopefully it'll appear on the screen, and I'm only going to rewrite the table with those values. So I'm going to have 0, 3, 5, infinity, and then infinity, infinity, and 2, and then I've got 0, 0, 0, and I'm going to put in my lines to make it easier for me to work with. So like I said, I'm going to now refer to the first row and the first column. So I'm going to use that, and I'm going to use that. It's a bit hard to see. I'll undo that. I'll change the color. So what I'm going to do is I'm going to work out this cell. I'll change its color as well. I'll work out this cell first. Now that is B and C. You can't see the C at the top, but there's a C there. So to do that, what I'm going to do is I'm going to say we'll have B, the distance of B to C. Can't see that either. Just need to scroll down a little bit. Here we go. Size all right. B to C. We're going to work that out by looking at the distance from B to A plus the distance from A to C. So currently this is using A as the intermediary node between A and C. Sorry, between B and C. Our algorithm goes K, I, J. We want to find the distance between I and J. We're checking to see that it is less than the distance between, we'll leave them all then. If the distance between I and J is more than the distance between I and K plus the distance between K and J, then the distance I to J is upgraded to the distance of I, K plus the distance between K and J. That'll make more sense as we go through. Once again, you can't see that. I'll just scroll up a little bit so you get a look at it. Now I'll go back down because I'm going to do some writing. Okay, I will also undo all those things so that I can write there in a few minutes. I can't pause what I'm working with and keep recording, which is really frustrating. I need a bit of screen recorder. Anyhow, this will do for now. So the distance of B to C is currently 1 because that's what we've got there. So I'm going to say 1. Now I'm checking the distance between B to A. B to A is infinity plus A to C, which is 5. Now anything plus infinity is going to be infinity. So unfortunately, 1 is the shortest distance we're going to get. So I'm just going to leave 1 there. I'm going to do the same thing for B to D. So I'm going to say B to D. We go B to A plus A to D. B to A, we already know is infinity. A to D is also infinity. And infinity plus infinity isn't 2 infinity, it's just infinity. So 2 is still less than infinity, so we're going to put a 2 there. Let's check for C to B. C to B, we're going to go C to A plus A to B. C to B, so C to A is infinity, so just like before, we're going to have to leave this as infinity. We've got C to D, so we'll check C to D. C to D is C to A plus A to D, once again infinity, so 4 is our lowest value because C to A is infinity. Next, let's have a look. Hopefully one's going to change. I'm going to have a look at D to B. So that goes D to A plus A to B. D to A, if we look, D to A has a cost of 2 plus A to B has a cost of 3. So D to B will cost 5. Is 5 less than the infinity we've got? Yes, it is. So we're going to put a 5 there. We'll do the same thing for B to C. You can't see that. I will write it somewhere else. So B to C is, sorry, not B to C, D to C. D to C goes D to A plus A to C. D to A has a distance of 2, as we found before. A to C has a distance of 5, so we end up with 7. 7 is less than infinity, so we'll put 7 here. So our first iteration, where we've used A as the intermediary node between all the other nodes, has resulted in that matrix there. So what I'm going to do now is I'm going to take that and I'm going to use that and I'm going to make B the intermediary node. So to see that in action, I'm going to scroll up. I'm going to scroll up here and I'm going to rewrite that table. So it is 0, 3, 5 infinity, 0, 3, 5 infinity, infinity 0, 1, 2. Infinity, infinity 0, 4, and 2, 5, 7, 0. So that's my table, and I am going to, no, not that, and I'm looking at the first, now I'm looking at the second row and the second column, and I'm going to try to work out every other node based on that, or the distance to every other node based on those values. So I will start with A to C. So A to C, I'm going to go from A to B plus B to C. A to B is right here, has a cost of 3, plus B to C is right there, it has a cost of 1. So we have a cost of 4. Is 4 less than 5? Yes. So I'm going to change that value to 4. Now I'm going to try A to D. And from there I'll say A to B plus B to D. A to B, we already know that is 3. B to D, right there, we see that is 2. So we end up with 5. So B to D, so 5 is less than infinity. That's going to be 5. The next thing we'll have a look at is C to A. I'm going to write over here, I've got still a space. C to A goes C to B plus B to A. C to B is infinity, so we're not going to update that. We'll have a look at C to D. Goes, my pen's not working now. Hope it doesn't run out of battery. C to D, whoops. use my finger now. C to D. We'll go C to B plus B to A. Well, C to B is already infinity. We're not going to update that. We'll try D to A. See if my pen works again. Yep. D to A goes D to B plus B to A. So D to B has a cost of 5 plus B to A. B to A is infinity, so we're not going to update D to A at all. So we're going to leave that there as 2. D to C. We'll go D to B plus B to C. D to B is 5. B to C is 1. So we end up with 6. 6 is less than 7, so I'll update that to 6. Then we go through the same process, except we're going to use C as the intermediary node. So to do that, I'm going to rewrite this matrix, and then I'm going to scroll up some more. We'll say 0, don't know if you can see this yet, yep, 0, 3, 4, 5, infinity, 0, 1, 2, infinity, infinity, 0, 4, 2, 5, 6, 0. Put in my lines to make it easier to see. And like I said, we'll go through the same thing, except we're going to use C. So highlighter. So we're going to use C. So we'll try A to B using C, so A to C plus C to B. We can see A to C is 4, C to B is infinity, so we're not going to update that. We'll have a look at A to D. A to C plus C to D. A to C has a cost of 4. C to D has a cost of 4. So it's 8. We're not going to update that 5. And then we go through and we do that for all the other values. I will just trying to think how I can show you the final answer without going through it. If you have any questions about what the final answer is, let me know, and I will provide them. I'll provide them to you, or I might make a note somewhere so you can actually see what the final answer is, because it's starting to be a very big file. But that's the way you go through Floyd Warshall.